Hello and welcome back to a new video on my developer journey of implementing a web server from scratch in C++. In today's video, I want to talk about the HTTP stack that I have implemented. This is by no means a video of the full stack. Now, currently, I have only a very basic stack of HTTP in my implementation. There is many more things that could come that I want to talk about, but for now, I at least got something working. Now, before I want to go too much into detail, let me actually start the web server and open a Firefox window, so that we can actually take a look on what's going on. You can see that the console is actually quite more filled with messages. If I zoom in a bit, this is because I've also implemented some system detection stuff. Yeah, which is gonna be important for me in my current development process, but it's not ready for video yet. Now, basically, what I've changed is if I now connect to the localhost, you can see that I get error 404. So I have an error that I can't reach the page. However, what I can do is I can access certain sites. For example, I have the index, and if I take a look at the index, you can see that we are actually getting some HTML. We are getting a title, and the actual HTTP protocol is correctly implemented. The request is parsed with the index, and I get a response. For example, there's something called fat, which is basically a fat HTML file. This is just an email template that I've taken from this web page. Just searched for a single page template, and I find the templates from this website. This is quite cool. Because they do have this available, and they have like a 1.1.1.3 I think, and I've downloaded that one. I'm not sure. Password plain text. I think this one is free. I'm not sure how you can get this. However, I just googled it and I found it somewhere for download, and I've just used it as a plain text here to just showcase that it works. Like you can see that it's styled. It's having buttons. It uses quite some features of the HTTP, not of HTTP, of HTML, and I just have done that to make sure that everything works, that different sizes work, and that everything is good. Now, basically, what we have now is, from what I have here, we could already start implementing an actual web server. We have everything until that point ready that allows you to now develop web apps with this C++ application. However, I do want to go further with that. I want to go further because, of course, I want more features, more advanced features. I want to have at some point scripting so that you can actually write the processing in a scripting language. That's going to be very simple. Of course, if you're asking me what is the purpose of writing a scripting language and not just use an existing framework, well, we're going to see when we process. But in general, now, if you have all these features like HTTPS, this parsing, if all of that is done, you more or less can implement apps now. Now, how did I implement that? Well, basically what I've added something on top of, let's terminate that. That is not too important, but I want to do it though. Basically what I've added something on top of the TCP endpoints of these queuable sessions. Currently, we have queuable sessions which can send and receive data, and I've implemented something on top of that that can receive an HTTP request and can send a HTTP response. Talking about the HTTP request, this is the header for it. You can see that we have certain things in the HTTP request itself. So you can see that we have a temp struct. This temp struct is temporary data that's required during parsing. It's a self-reference to the request. It is a memory allocator and the active header field. You're going to see later on how this all comes in place. Then we have the definition of itself. It needs an allocator that's required always. And if you want to directly get started and kind of like parse the request, you can provide the buffer and the buffer size, and this buffer is then parsed, which is basically how it's going to be used. I just want to have a default constructor because you can copy around. Now, after the request has been parsed, I can check with the method, which HTTP method was used. I can get the URL. I can check if there's a header available, and I can get a header. This is basically the interface. Internally, it's stored the method as a field, the URL as a field, and an unordered map from string to string with the header fields itself. The request method comes from the HTTP protocol. We have the HTTP protocol defined here in its own file. You can see that we have all of the HTTP methods that are available, and we also have all of the response codes that are available and implemented. And I also have a way of taking these response codes and converting them to a string, because at the end, the response code needs to be sent like that in the response, but that's what we're going to talk about in the response itself, but just so that you know this header and I don't need to come back to it. Now, internally, there are a few callback functions that I'm going to talk about later. Now, how do I implement the parsing? Of course, I do not have implemented my own parser. This wouldn't be a good idea. There's something really good that's existing. It's called LLHTTP, which is, I think, from Node.js. As far as I'm concerned, the parser that sits in Node.js behind requests is LLHTTP. And this is basically, I don't know if it's even written in C. I think it's a combination of C and TypeScript. I don't know. It's actually, I think, not even completely implemented in C. It might still be. I have no plan. However, I don't care. It has a C API that we can use. Now, you can see that to use it, we need these settings. And if we want to kind of like initialize these settings, we're calling settings init, which is basically setting them to some default values. After that, I can configure how I want to have my parsing. And basically what I do is I change the callbacks. So basically, the settings object holds a set of callbacks. If I peek in there, in there, you can see that if I go do that, we have a struct, and there are like all of these on functions, and these are all basically all callbacks that are called on a certain case. For example, on this is, I think, for these chunks are for the HTTP 2.0. But for the normal HTTP, they are like on URL, on status, on method, on version, on header field, on header value, and all of these things on headers complete. So as soon as the headers are completed, if there's a body, then on body is called. So basically every time the parser reaches a certain key point, it calls these callbacks. And basically what I've done, I've bound the ones that I'm interested in. So the method is completed, the URL has been sensed, the header field has been sensed, and the header value has been sensed. I'm gonna put that into my own callbacks. So the callbacks basically then modify the state. To use these callbacks, because it's a C library, we need some object that allows us the access of our request. So this is the temp object. So we have a temp buffer. I'm going to provide this pointer and the allocator. And additionally, I have the string of the active header field, because the on header field is being called when a new field starts, and the on header value is called when a field's value is received, but I no longer have the reference to the field's name. So I store this internally to then know where to put the value. After that, I can start setting up LLHTTP. It's just done on the stack. I can initialize it, and I tell it that I want to pass a request. It can also pass response, but in our case, we just want to have requests parsing because we're implementing a server. In the end, we might also parse response if we might have interaction with other APIs on the server. Then we also need to parse response, and we can use an LHTTP as well. You can see it's initialized by providing the kind of like state, the type of parsing, and a settings object so that it can be initialized. After that, I can access the data field in LHTTP and put it to my temp buffer, or a pointer to my temp buffer, better to say, to later on access my temp buffer when the callbacks are called. Now, after that, I can run LLHTTP just by basically providing it the buffer and the buffer size. Really simple. If the code is not HBOK, it means we have an issue. We can log it and we can throw. Now, basically what it does is it will parse and call my callbacks. You can see that the callbacks, they are implemented here. And basically, for example, on method complete is called when the method has been parsed. Now, basically what I get is I'm going to get my temp buffer. It's done as a reference, and I'm just going to cast it to a temp reference. And then what I can do is I can switch on the current method on the method of the context. So basically, after this method completed has been parsed, this field is valid, and then I can have a big switch case, and I can assign the kind of like my enum values to the method instead of the LLHTTP ones generated. Now, as soon as I have a URL, I basically just store the URL in the request by moving it, and I'm moving a newly crafted basic string with my allocator that's in the buffer, and yeah, just provided the add and the length that is kind of like given in the callback by LLHTTP. And this is also how the other ones work. Just that in this case, if I have a new header field, I'm storing it in the active header field, and then I'm placing it in the map of the request. So basically, it's just a very, very simple moving data from A to B, kind of like paradigm. It's not complicated at all. It's really, really simple. Now, this is basically how request parsing works. How did I implement this in my main? Well, let's go into the main and let's take a look where we are at. Now, currently you can see this is what I've implemented to read the data from the user. I don't think that we had this previously. We are getting like the session. If we have a session, then I am allocating a buffer of a certain size. I am receiving the data of the certain size. And then what I'm gonna do is I'm gonna get the size that I have received. I think this is a new one that I've implemented so that I get like a feedback how many bytes were actually received. And what I then can do is I can parse them. I'm basically just creating my request, and then it's good, and I can deallocate the buffer that I've used for reading the data. And then I can basically just echo out what's happening, and then I craft a basic response, right? I have a buffer size, create myself the buffer here on the stack. Then I'm gonna actually parse the URL that was requested. I'm basically creating myself a path from the current directory, the URL that has been requested, and I append the .html, and then basically I load this in. You can see here I allocate the response, and then I actually read in the file. So HTML file is created. If the stream is open, I'm gonna get the size of the stream. And then I create a response message, a basic string, resize the string so that everything fits, read the data from the file. Then I put the content in the response. Oh, we haven't talked about responses. I'm currently rushing a bit through, but yeah, this is how responses work. We can take a look at the API later. Like then I append the header to the response. I'm basically telling the content type. Then I provide the code, the HTTP code, build a response, and I do the same thing if I don't find the file with error 404, with plain text and the 404 code, and then build a response. After that, down here we have a bit of a response build up, and what I've added a performance counter for the memory usage, but that's something that we're gonna talk about later. So memory usage is kind of like detected and counted, and at the end, or I'm also printing how much memory kind of like was used by the counter. But yeah, this is not really too much what we want to talk about. We want to more talk about the response in itself. So how does the response work? So basically I have defined myself a data type for header fields, which is basically a key and value pair. Then I have the HTTP response itself with an allocators and a headers object. So which headers we have. We have a build headers, a code, append header, and content function. So basically content provides the content of the response. Append header provides the header, or appends a header to the list of headers. Code is going to set the response codes, and these build functions are used to build the actual data into a buffer. Now, internally, I have another function that I'm going to come back later. So I store a response court, and in the CPP STD list, so an STD list of header fields, I store my headers, and internally also the content size. Adding the content is quite simple. I can do it for a string view. If I do it for a string view, I am basically going to extract this to the void pointer and size interface, and if I am adding data, basically I'm just writing to the members internally. Now, setting a header is a bit more involved because I need to make sure that I kind of like do it correctly. Basically, what I'm doing is I'm allocating a string for key and value based on the string view and store it in a new header field, which I then move into the header. So I move it to the list that I have internally. Code is also simple, just do a assignment. Now let's talk about how everything is built up. So how do I build now my headers into, or not my headers, my whole response, how do I build them into a buffer? So basically the first thing that needs to be happening is the headers. First we need to commit the headers, and if we have commit the headers, we need to commit the actual content. Now I have done this in 2 functions, so that in theory you could even commit the headers before the content has been sent to make it a bit more asynchronously. So this is just on how it could be optimized later, and bit separate this. Now, in general, what I've implemented is myself is a buffer writer. The buffer writer basically just gets a pointer and the size, and it basically throws as soon as you're trying to overflow the buffer. So this is actually quite simple. So if I have a buffer writer, I can just call out.write with my content and content size, and everything is good. And then I return the out size plus the header size, because build headers is of course also inside of the buffer. This is also why I'm offsetting the buffer as soon as I'm creating a writer for the content, and then I can get the total size out here. Building the headers is very simple. We start the same with a buffer writer. Then I'm going to commit the content length. Since we are on HTML, we also need to tell the client how long the content is to be expected. And commit content length is going to write the header that basically indicates how many bytes are kind of like allocated. Or shall be allocated for the response, so that the response can be read. Then I start the HTTP protocol onto the buffer. I am starting with HTTP version. It's HTTP/1.1 and I think a space because we then need the code. So then I'm gonna go for write string, and I'm providing the HTTP response code string function. So this function converts the internal code, the number, to a string. We already have taken a look at this at the HTTP protocol file. So this is the HTTP protocol file. It's basically that big switch function, which might be even translated to a, could be translated to a table. I'm not sure how it's implemented. But yeah, then I am providing a R&N, so current return new line, which basically means that this is the first line that's finished. And after the first line, which indicates the protocol and the response code, the headers will follow. So how do I write the headers? First of all, I need to iterate over them. That's really simple with STD, and yeah, this shows the power of using my own abstraction over STD, because I have my memory management, my save memory management, and I have the convenience here of the standard library. So here you can see that I'm iterating over all headers. I first write the key, then I write a colon and the space, then I write the values, and then again a R and the N for the next line. This continues on for all headers, and after this is done, we need to have one line that's completely blank to indicate that now the content is coming. So I'm writing R and N again, and then it follows by returning out.size, which basically tells how many bytes were occupied by this buffer writer for writing the headers. And then, of course, it can continue on and everything is good. And at the end, well, we already take a look at the usage. This is how it looks. If I take a look at my Visual Studio Code, you can see that here's my index.html, here's my fat.html, and we could make a new file and call this one bootstrap.html. Let's call it bt.html, because I am not good at writing some complicated stuff like bootstrap. And then I can say like get bootstrap which is like a CSS framework. And if I now go to get Bootstrap and I go to the docs and I get started with the Hello World example here, I'm gonna copy this over and I'm gonna save it. And now if I start, if it says running, no, it's not running. So if I now start the web server by pressing F5 and I request a BT page, you're gonna see that I can of course access it because, well, I am just accessing that file. And here we have the Bootstrap Hello World example, which looks ugly. So I could even go in here and I could go to something like, are there templates, components, templates? Come on, there are starting. There's like this album template. Album template, starter template. No, come on. Bootstrap 5. Bootstrap 5 music website. No, not Team Forest. I want to have the album example. And I can basically be really harsh and just copy this over because this one should work as a template. And now I can go in. I hope that my server is able to fulfill these requests, but it seems like we are having issues about the path. Yeah, because it's basically going from somewhere else. I hate that it does that. There should be... This is a bad example. Why is there no Bootstrap example? Headers, heroes, features, flavor. Let's go for maybe pricey example. Has this? Why are you always going into these? Well, I don't have the code currently, but I do have it. But I could serve everything, but I do not really have Mimi types working. So if I would have Mimi types, I could just duplicate this folder and it would work. But it does not. But yeah, I can put some stuff in here, and I can go back in there and refresh, and I get stuff. But it doesn't work, of course, because Bootstrap. I don't know why you're not using CDN example. Bootstrap CDN example. Getting started. Introduction. Get Bootstrap. Get started. Bootstrap CDN. CDN template single page. Let's see. Bootstrap one page templates, starter templates, complete Bootstrap starter template with predefined, but that's not a starter template. This is HTML template with CDN. Come on, this is not what I was looking for. I don't want to have a blank template, but I do. Bootstrap theme company. What is that? ASP. Create a theme company. Nah. Is there a single page for that? It looks like. Can I get the source for that? Aktueller Frame. Frame in neue Tab öffnen. This is what I want. I want to have this looks good. This looks like it's probably inlined. So let's paste this one in here. Let's hope that they save the world for me. And it might look like they did because, yeah, the server has crashed. We can't write to buffer. Overflow would occur. I currently don't have any dynamic buffer management in here, so basically we're gonna double the buffer size currently, and it's gonna work. This is like why this is not ready yet, but it's already at a good point. I just want to show you that it works, right? Here you go. This is now a fully Bootstrap working template. I hope that even the images work. Probably they should. Or maybe not, they seem like to be on the same server. But you can see that this one, it's probably trying, yeah, it's trying to get New York.jpg, which is error 404. But we have the all texts available, so you can see they are all in here. You can see that the design looks good, and you can see that it's almost ready to to be used in a professional way, the web server. As you can see, it is not that big of a deal, right? We have now had a few videos, and even if you are not doing like this memory stuff, performance counter stuff, this is all stuff that I am just adding because I want to make this one battle-proof. Also this queuing stuff, and I'm now also gonna write a task system, and also like this OS API, which is completely new, that I also want to talk about at a certain point. This is all new stuff that are just for me because I want to make it a bit bigger. But if you want to just write a very, very simple web server, just with the standard library, just allocate a string, directly pass in the string, don't like cache the response or stuff on there. You could do it, right? It's a really easy thing to to work with. It's not hard. It's simple, and it's not that hard, right? Like the actual HTTP stuff, like 90 lines of code. This is the request. The response, even less, 77 lines of code. This is actual HTTP. Abstracting away a SSL socket. It's also with like OpenSSL, ASIO, and a bit of LLHTTP, and maybe then even nloma JSON. It's really simple, right? If you write an application, it has an API, you're not gonna even need like fancy stuff that you need to implement. You just have a certain hard-coded API endpoints, or maybe you're even writing your own router and write a register function to kind of like register certain endpoints, and then you just use nloma JSON, serialize them, and just send them out. And it's really easy to implement a web server in your application in C++, and that's really the case. You can do it on your own. You can of course use use libraries and stuff like that, but yeah, it's all good. Now, something you can see here are these errors. That's actually not a problem because sometimes it cannot accept bytes, which is okay. If it fails accepting bytes, I gotta get an error here, but that's not too big of a deal. All right, so yeah, that's kind of like the idea. It's really simple web server. It's definitely not a problem. It's just what it is, and I can continue on writing. And the next thing that I'm implementing is a job system to actually now schedule multiple jobs, and then I can gonna start reworking everything so that the sessions flow in the job system as they should flow. And that basically what we'll do is we're gonna just have jobs that are executing, and at some point I do want to have an API that or like a container where you can register what happens for certain routes, which jobs to launch. And then at the end, yeah, the server will just implement a set of API of like jobs, like the show users job, show index page job, and then internally there's just a bit of boilerplate code that just tells how the flow should be, and then yeah, probably some scripting. So it's not too much of a deal, right, actually. And then we're gonna start at some point getting in all of this middleware stuff. So yeah, this is then gonna be more interesting. But for now, that's it. That's simple, and thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.